Alright guys, I'm actually back from dinner. It's 9 o'clock. Oh man, what can I say? I just spent like the past 1.5 hours watching anime and all this computer stuff I have to do, this job stuff I was talking about. It's due at 12 o'clock tonight, or actually 11:59, so I have exactly 3 hours to finish everything. Man, I hope I can finish fast. I'm gonna try to finish as fast as I can. I'm not gonna take any notes. But yeah, let's do this. So we just learned about wrapper classes. Now we're taking the quiz on it. The purpose of a wrapper class is... Okay, the thing is, I want to work fast, but I don't want to get these wrong. So... Yeah, man, I was watching Kill la Kill. And something weird happened. I'm not going to spoil anything, but... I can't concentrate. All I can think about is that plot twist. The purpose of a wrapper class is to wrap an object, to wrap a primitive value to convert it into an object. I guess. Okay. What happens when a double is unboxed? A double is unboxed. No, I guess kind of. There we go. Java automatically converts between objects and primitives in the process of autoboxing and unboxing. What happens when an int is autoboxed? Converted into an integer. Which of these is not true about primitives and objects? This third statement is so trippy I can't read it. When passed to a method, changes made to the object will show in the calling method. When passed to a method, changes to the object will show in calling the method. Changes to the primitive will not. A primitive has data and methods associated with it, while an object only stores data. Okay, that has to be the correct one. There we go. Integer y equals 12. Print an int back to an int to print. So yeah, I'm trying to just speedrun everything. Maybe I should title this Speedrun episode. Double value. Oh, does that not work? Int whole number equals int x double value. And we said x was 16.8. I mean, that did work, right? But I guess, well, let's try this. Double cannot be converted into int. Okay, nice. I see. Nice. Display menu. Oh. Okay. Interlabel. That is so weird. Why do I need to do that? Oh, because I have to turn the string into an integer, but I can't set a string equal to a number. Oh, it's weird. Does that work? Integer value of Bro, I had to write like 3 lines and I still got something wrong. What? Yeah, I didn't think that would work. I'm just gonna test what happens. So I was right the first time. Okay. Secret item. Double rounding error. Okay. What was it? Value. double value. Yeah. Wait, I'm stupid. Oh no. I can do that? Oh. I can use other methods in a method. Smart. What? What? That actually works? No way. Okay. Use another. Okay, gotta go fast. I only have 38 in 2 hours. 2 hours and 30 minutes. Why do I keep on saying burger? Like that burger. It's not really burger. Is that one? Okay, now.
心肝冷不冷的？不能哈个关。心肝儿。
I'm recording.
等一下，星星上去哈，妈咪要睡觉了哈。啊，BB。
Shouldn't this return the difference between number and min? It's weird. I mean, technically this should all be just absolute value, right? But we don't know how to do that. Okay, we finished 2.9 in about 30 minutes. We just have to finish the rest in 2 hours and 30 minutes. We can do this, let's go. Also, I'm still a little bit stuck on these, so.
Hi, in this lesson, we'll take a look at the math class. Let's dive in. As we learned earlier in the unit, instance methods need to be called with an object of the class. Whenever we've wanted to use one of the rectangle methods, we've had to call the method on an existing rectangle so that we could use the data from the rectangle in the method being called. But is it possible to create a method without creating an instance or object of the class? In fact, there is a way to create methods that don't require an instance of a class to work. Static methods are methods.
I lied. I said I wasn't going to take any more notes.
Methods that can be called on an existing rectangle so that we could use the data from the rectangle in had to call the method on an existing rectangle so that we could use the data. Data from the rectangle in the method being called. But is it possible to create a method without creating an instance or object of the class? In fact, there is a way to create methods that don't require an instance of a class to work. Static methods are methods that can be called without creating an object. A static method of a class is common to all instances of a class. And is not called on an object instance. Static methods can be used anywhere in your program. To create a static method, we simply need to include the keyword static in the method declaration. method, we simply need to include the keyword static in the method declaration. This indicates that the method can be used by the class name itself, and not necessarily through a class object. Let's say we wanted to create a method that reminded us of the different equations that we could use on rectangles. We could create a static method that printed both the formula for area and perimeter. Now that the method rectEquations exists, we can call it using the name of the class it belongs to. When rectangle.rectEquations is called, it executes the method even though there is no existing rectangle object. One class that exclusively contains static methods is the math class.
Oh, if I need to do something.
The java.lang exclusively contains static methods is the math class. The java.lang.math class contains static methods for performing basic numeric operations. such as the elementary. The math class is part of the java.lang package. This diagram shows a small part of the java.lang package, which we have covered in this unit. The java.lang package provides classes that are fundamental to the design of the Java programming language. The math class contains only static methods. To call a static method in the math class, use the dot operator with the class name followed by the method. You want to use. We don't need to make any instance of the math class in order to use any of its methods. Having to create a math object each time we wanted to utilize a math class would be a tedious process. Static methods allow us to simply use the class name to call methods in the math class that we want to use. In fact, if you try to create an instance of the math class and use it to call a static math class method, the compiler will throw an error. For static methods, you can only use them without instances. The next few slides will cover 5 common static math methods and will be very useful in your Java programs. They're also a part of the Java Quick Reference, which means they can be tested on the AP exam. You can evaluate expressions that use the math class methods in your programs to help solve problems. Here are a couple of methods from the math class that will be helpful to us as we continue coding more complex problems. Let's take a look at the first method, math.abs. Math.abs returns the absolute value of the numeric value that is input in the method. Let's take a look. Look at the first method, math.abs. Math.abs returns the absolute value of the numeric value that is input in the method. There is a double and int version of the abs constructor, so whichever type is input will be returned as an absolute value of the same type. The next method is math.pow. Math.pow allows us to create programs with exponential values. Pow takes the first input and raises it to the power of the second input. The third method is math.square-root. We can use math.square-root to get the positive square root of a double value. Finally, let's take a look at math.random, double value. Math.square-root to get the positive square root of a double value. Pow, an int version of the value of the same type. Programs, this method is math.pow. Math.pow input and is math.square root of the second input. Finally, let's take a look at math.random. Math.random returns a random double value greater than or equal to 0 and less than 1. When and why would you need to use random numbers in a Java program? As it turns out, random numbers are used in lots of places in programming. They can be used in games like rolling dice, flipping coins, shuffling cards, and more. They can also be used in simulations and for security systems, like in creating secure keys in cryptography to make data secure to send and receive. You can use random numbers anywhere you need some level of unpredictability. While generating random numbers can be very useful, we usually need to do something with them in our programs. If we are rolling a dice, selecting a card from a deck, or we just need a whole number for our application, we can do a little more to get whole numbers from our random numbers by defining a range and multiplying. Let's walk through how to do this. The values returned from math.random can be manipulated to produce a random int or double in a defined range. For example, like the numbers 0 through 9. Let's dive into this code on the next few slides. Every time math.random is called, a new decimal number between 0.0 and 1.0 is generated. We then multiply that number by 10 so that there is a number in the ones place. Next, the number that was generated is casted, which drops the decimal values from the number and leaves us with the positive number between 0 and 9. We can repeat the process as many times as we like and generate as many random numbers between 0 and 9 as we want. While that only gives us numbers from 0 to 9, the general formula for getting a number from 0 to any range is int parentheses math.random times integer plus 1. Let's take a look at how this expression works. As we already noted, math.random creates a random integer from 0 to 0.999 repeating. When we multiply it by integer plus 1, it changes the range of the numbers produced to 0 to the integer 0.999 repeating. The reason that we add 1 to the range that we want is due to the fact that the integer value is not included in the range if we multiply by integer produced. When we multiply it by 0 to as we already noted, let's take a look at how this expression works. As we already noted, math.random creates a random integer from 0 to 0.999 repeating. When we multiply it by integer plus 1, it changes the range of the numbers produced to 0 to the integer 0.999 repeating. The reason that we add 1 to the range that we want is due to the fact that the integer value is not included in the range if we multiply by integer. If we multiply any value from 0 to 0.99 repeating by a number, the range of possible outcomes will be 0 to the number minus 0.0001. Because casting to an int removes the decimal values from a given number, multiplying by the number we want included in the range will never actually include the final number in the range. If we add 1 to the range, then the range, when multiplied by number plus 1, will be 0 to the number 0.9999 repeating. Now, when we cast to an int, that number will be inclusive in the range. Finally, the int casts the number to a whole number that can be used. For example, if we wanted a random number between 0 and 5, we would plug 5 into the integer variable slot and write the expression as such. When math.random is called, it creates a value between 0 to 0.99 repeating. That is then multiplied by 6, which creates 0 inclusive in the range. Finally, the int casts the number to a whole number that can be used. For example, if we wanted a random number between 0 and 5, we would plug 5 into the integer variable slot and write the expression as such. When math.random is called, it creates a value between 0 to 0.99 repeating. That is then multiplied by 6, which creates a value between 0 and 5.99 repeating. That number is then cast to an int, leaving a random number from 0 to 5. If we wanted to change the start of the range to be 5 to 10, we can do so by adding 5 to the end of the math.random equation. Because the lowest value possible is 0, adding 5 to the end of the equation will make sure that the lowest possible value will be 5. Now, when int is called, the possible range will be from 5 to 10. Here's the general formula for starting a range at a specific starting value and going through a specific formula. The possible range will be from 5 to 10. To 10. Here's the general formula for starting. For example, if we wanted the starting value to be 100 and the range to be from 100 to 150, the 4 plus 1 ran documentation for them right in the CodeHS editor. Be sure to check the Docs tab for all the math methods available. Now that you've learned about the math class and several of its useful methods for evaluating expressions, let's get some practice using them in the editor.
Oh, I don't know if you guys know, but I like math a lot. The absolute value. I didn't see that. Shoot. Shoot. Oh. let's not get too upset over that. That's why you don't go too fast and too confident. I was gonna make silly mistakes like that. You know, that reminds me of the end of the year. I had a math test, man. Oh, I made the worst silly mistake ever. I did the hard question, but I forgot to take a picture of it. And I forgot to upload it because I didn't have a picture of it, so I didn't get the credit for the hard problem I did. Ah, that was so sad. I was like mad about that for like a couple of days. I keep on getting mad about this kind of stuff. You hate yourself over these silly mistakes. Seems like there's a trend of these static. Well, I guess that's not always true. Oh, I tell you right there. think I forgot to do something here. Wait. Oh. I thought that was theta for a second. I was so confused. It's 0. It's not theta. Bruh. What am I supposed to do? Java methods need the angles to be in radians rather than degrees. Okay. Print out the angle, cosine, and sine of the angle. Okay. Bruh, they already printed that. Are you kidding me? I didn't even do it right. Why do you have to round it if you're getting the... Man, I would use a method for this, like a method from a different class, but like a, you know, like a function, just to like output that. Man, I almost forgot the semicolons again. was like, look, if you had a method to do all of this, you didn't have to reprint it like that many times. Oh wait, that's not that. What is that? Is that? Oh, 5 or 2 radians. Okay. Bruh. Why are you bullying me? What the heck? And you might have to delete each copy paste like that if you had the method to do it. What? Bruh. Still no? Bro, how is that even fair? What is it? Oh. Actually, I guess it's not that bad. I thought it was gonna be a lot worse. But they have the mathed out route already, so it's okay not to make your own. Okay, now it should work. Assuming it does the operations like I want it to. In the order that I want it to. Bro, ayo, hello? I think something bad happened. Bro, I thought I did the math round. Oh my god. Actually, it's only the cosine that's not working. I'll do it on the sine anyways, just so it looks symmetric. There we go. Racing. Fun. I love this. No. Physics. I lied. What's the race car class that's completely use compute time method? Mm-hmm. I don't get how people make physics equations. It's very hard. I was thinking like this. Even the basic things like electromagnetic field calculations, bruh. Apparently, you have to do like all kinds of calculations with like abstract algebra, like linear algebra, vector algebra, these vector space equations. Oh my gosh, lots of calculus. Whew, it's a doozy. I don't know what the range for acceleration should be. Should be greater than 1. Meters per second squared. Why are all of these in miles? I don't understand. Let's just make up a random number. 1 to 100. So, people that's okay, right? I'm pretty sure the only race car attribute is acceleration. Never mind, you have to have the name of a driver. Funny. Funny. I called that thing places. I don't math around to the nearest integer. Bro, why do I need to give the name of a driver? Alright. My first first driver is going to be called what was it? Acceleration string driver. Okay. Susanna. That's a good name. I think I spelled that wrong. I'm sorry. Our second driver. Race. Car 2. Their name is gonna be Vicky. Alright. Actually, I'm gonna change their name to Nick Company. This means that oh, how nice. They found the equation for us. Two times distance divided by XL. Yes, I think that is correct. Oops, what am I doing? And I know you're thinking something, I'll fix it really quick because I did not forget about it. Okay. There we go. Now everyone's happy. I want to see if this round actually works, because it did say it would round to the nearest integer, so I'm not sure how it would round to a decimal. What did I do? I forgot how to make objects. So sad. Oh my god. Death. my result. It wants me to do math.run on that. Bruh. Wait. It does do the nearest integer. Because that was my result, right? So I'm just gonna have to do times 1000 divided by 1000? Is that even capitalized? I don't even know. That means my other part's gonna be wrong too. Bro, are you... Math.run. How did I get that wrong? If you divide that by 1000, wait. Oh man, those don't sound like fireworks. Oh, I did. Never mind. Maybe math round is... Is that what it wants me to do? I'm so confused. No, frick this. This one goes to that one. Maybe there's some round thing in here that can. Oh, that's where pile is, bruh. I can get floor, but that's not round. If I use that, I'd have to use conditionals. With ties rounding up? Closest along to the argument. Bruh. How does that give me? How do we round that to this? Oh my god, it works. I had to use rent, cause watch this. They lied, bro. I said I was supposed to use round. Round doesn't work. Oh, it gives different inputs too, cause it's random. How cool. I want the second card to win. I mean, the second card to lose. Okay. I hope using rent is not cheating. Alright. Let's see if anyone answered my question. No. Okay, I'll just submit it as it is then. Looks like we still finished up a bit of time left. That's good. Assignments. Oh, dashboard, yep. Thanks. I'm just submitting my homework to my teacher right now. You know, for some reason, I think it might be OBS or Discord. Let me close Discord. Let's try. Yeah, I can't use my snip tool anymore. It's kind of weird. At least I can't mark it up. Or maybe it's here? No. Alright, well, I'm gonna try closing OBS then. That was it for Speedrun Java Part 2 of Day 2. I hope you guys enjoyed watching that. I'm a bit tired, but yeah, I learned a lot of Java today. Got lots of work done. Let's go.